Hello and welcome to this class. For this class, we'll be looking at the study of isomerism in organic chemistry. So let's look at the concept of isomerism. First things first, I will define isomerism. Then after definition, I will give you some basic types of isomerism ranging from the chain isomerism, functional isomerism, and geometric isomerism. I will take few problems to explain those types. First, let's define the concept of isomerism. By definition, isomerism is the existence or occurrence of two or more compounds with the same molecular formula and different structure. Usually, isomerism exhibits chemical properties but slightly physical properties due to the arrangement of atoms in space. That's isomerism by definition. Let's look at the next concept called the type of isomerism or types of isomers. Types of isomerism. Alright. When it comes to the types of isomerism, there are three distinct types of isomerism. So the first one there is called the functional isomerism, or you call it functional isomers. So functional isomerism. The second type of isomerism that we have there is called the chain isomerism. And finally, we have the last one called the geometric isomerism. All right, these are like the three distinct types of isomerism. The first one is called the functional isomerism, chain isomerism, and we'll have the geometric isomerism. Let's explain these types one after the other. Let's have the first one there called the functional isomerism. Or if you want to, functional isomers. Functional isomerism. All right. Let's start with the first one, please. By definition, a functional isomerism is simply a kind of isomerism that in which two or more compounds have the same molecular formula but different functional group. So I'm saying that when it comes to functional isomerism, the two compound or the two or more given compound will possess the same general molecular formula, but they will have a different functional group. What do I mean? I will explain functional isomers using some examples. So let's take a few examples to explain functional isomers. And I'm saying that when it comes to functional isomers, the key concept to note are just two. The first one is called the general molecular formula, and second one is called what? The functional group. By functional group, I mean the alkane, alkene, alkyne, alkanol, haloalkane, esters, and etc. These are like your functional groups. So I'm saying that they'll give you two compounds. The text says that the two compounds will have the same molecular formula, but they'll be having what? A different what? Functional group. The first can be alkane, the other can be alkene, depending. Let's take an example to boost the explanation on this case. So an example that explains functional isomers. So let's take ethanol, and let's explain ethanol and methoxymethane, for instance. Let's take these two compounds and explain what functional isomers means. So for ethanol, let me take ethanol for instance. Ethanol. For ethanol, we know that et is two carbon atom So I'll have 1, 2. This is a 2 carbon atom, but I'm having the word anol. Anol there is a functional group for what? Alkanol or alcohol. That's OH. So of course I'll have a OH here. This signifies the anol in this compound here. Next task now, I have to balance this. We said for every carbon atom to be balanced, they need 4 bonding to be stable. This is 1, 2, 3, 4. This man is balanced. Balance up. This 1, 2, 3, 4. This is balanced. This is the structural formula for ethanol. Now listen. Let's get the molecular formula for ethanol and the functional group. It's clear here that molecular formula for ethanol is of course how many C? 1, 2. I have C2. How many hydrogen? 1, 2, 3, 4, 5, 6. I have H6 and then 1 oxygen. So I'm saying that the general molecular formula for ethanol is what? C2H6O. Let's get the functional group. Of course, we just said earlier that the functional group here is what? OH, which signifies alkanol. So this compound ethanol has a general molecular formula C2H6O, has a functional group alkanol, right? So that's like for ethanol. Let's explain methylmethane and compare the two. For methylmethane, the compounds look like this. I have this carbon here, the carbon here. So balance up. 1, 2, 3, 4. Balance. 1, 2, 3, 4. By the way, we said methylmethane. For methane, that's 1 carbon atom. But bear in mind that methylmethane is a kind of different compound, and the structure of methylmethane is CO to C. Are you good now? So in this compound, now this is methylmethane in its structural form. What is the molecular formula of methylmethane? It's easy. How many carbon atoms? 1, 2. I have C2. Next task, how many hydrogen? I have 3 here. With 3 here, that's 6. I have H6 and I have just 1 oxygen. So the molecular formula for methylmethane is C2H6O. Let's get functional group. Of course, there's a functional group that has something of this nature, and this is what? Esters. So the functional group here is esters, right? So it's the what's it called? The functional group is of this nature, and that's what I'm having here. The R signifies the carbon, right? So that's esters here. So I'm saying that to clarify the understanding behind functional group is that a functional group, the 2 compounds given will have the same molecular formula C2H6O, C2H6O, but what? Different functional group. Yes, alkanol. Yes, what? Esters. That's basically the concept behind functional isomerism. Let's call second type of isomerism called the chain isomerism. Number 2, let's look at the concept of chain isomerism. All right. By definition, a chain isomerism or a chain isomers is simply an isomers that has or that possess the same molecular formula and the same functional group, but different in arrangement of atom in space. So yeah, here's the concept. I'm saying that functional isomers will have the same molecular formula, but what? A different functional group. And for chain isomerism there, I will have the same molecular formula and yet the same functional group. That's the concept. So to bootstrap or to explain function isomers, we'll take a look at 2 compounds, right? So let's look at compound. Let's look at 2 compounds to explain chain isomers, a compound that will have the same molecular formula and the same functional group. Let's look at butane. Let's look at butane and we'll look at 2-methyl propyl propane, please. 2-methyl propane. Let's consider these two compounds to estimate if these two compounds will have the same molecular formula and the same functional group. Let's take a look at butane first. Butane, the word but there signifies 4 carbon atom. The word tane there signifies what there? An alkane. So it means for butane I'll have 4 carbon atom. 1, 2, 3, 4. 4 carbon atom. Balance this up, please. This is 1, 2, 3, 4. Balanced. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. This structure is for butane. No problem. Let's get the molecular formula of butane. How many carbon atom here? 1, 2, 3, 4. That's C4. Next task. How many hydrogen in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have H10 in total. So I'm saying that the general molecular formula for butane is C4H10. This man here are all strokes. They are all strokes. And a stroke carbon atom signifies a functional group called alkane. This man here is alkane. Why? Because I'm having what? A single bond all through. So I'm saying that for butane, the general molecular formula for butane is what? C4H10. The functional group is what? An alkane. Let's consider 2-methyl propane. Let's consider 2-methyl propane. All right, for 2-methyl propane, 2-methyl propane. All right, for this one here, by the way, the propane here signifies a 3 carbon atom. For 3 carbon atom, I have 1, 2, and 3 carbon atom. All right, now listen, I have 2-methyl. 2-methyl, the methyl here is a substituent. That's CH3. Now, this 2 signifies that position of methyl is at carbon 2. This is 1 and 2. Carbon 2 here, attach CH3 methyl to this place. When you're done with this, balance this one up. This is 1, 2, 3, 4. Balance. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. This man is called 2-methyl propane. This is, of course, the structural name, perhaps structural compound or formula for 2-methyl propane. Let's get out the molecular formula. How many carbon here? 1, 2, 3. That's C3. Oh no, sorry, I have C4 per se. This 1, 2, 3, 4. C4. Next task there, how many hydrogen in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I have H10. So the molecular formula for 2-methyl propane is what? C4H10. These man are all single bond, all true. That signifies an alkane. So I'm saying that when it comes to chain isomerism, the two compounds given, that these two, will have the same molecular formula C4H10, and also they will possess the same functional group, alkane, and of course I have alkane. This explains the concept behind chain isomerism, or you call it chain isomers. So a chain isomers is simply a kind of two compounds that possess the same molecular formula and the same functional group. Let's look at the third type of isomerism called the geometric isomers or geometric isomerism. Come back. Let's look at the third type of isomerism known as the geometric isomers. So let's look at geometric isomers or isomerism. Right, let's look at geometric isomerism. By definition, geometrical isomers is the existence of two or more compounds with the same molecular formula but are not identical due to their spatial arrangement of atoms in space. That's how you define geometrical isomers. Here is what you need to note when it comes to this concept. For this concept here, there are two types of geometrical isomers. So I'm saying that for this concept here, we have types of geometrical or geometric isomers. So I'm saying that when it comes to isomerism, when it comes to geometrical isomers, we have two types. The first one is called the cis. The first one is called the cis. Second one is called the trans. So it's called the cis and the trans system. So when it comes to geometrical isomers, there are two types. The first one is called the cis system and the trans system. What is cis? What is trans? I'll take an example to explain this concept much more better. So let's say I have, let me explain the two at the same time. Let's explain the two at the same time. So let's say I have a compound. Please bear in mind that when it comes to illustrating geometrical isomers, we deal with double bond. That's your alkene. So let's say I have a carbon this way, double bonded to another carbon this way. Let's say I have CH3 here. I have CH3 here, hydrogen here, and hydrogen here. Let's say I have another example this way. Let's say I have something of this nature. C, though bonded to C, I have my hydrogen here and my hydrogen here. Next task here, my CH3 is placed here. My CH3 is of course placed here. Now, what do you observe in the two similar examples I gave you? Now listen, here's the concept. To explain cis and trans system, please bear in mind that for cis, the hydrogen are placed in a linear pattern. Observe, I have HH. They are placed in what? In a linear pattern. That's for cis. For trans, the hydrogen are placed diagonally. Observe, diagonally. You can see that. So when it comes to cis and trans system, for cis, the hydrogen are placed in a linear format, in a straight format. Observe, hydrogen, they are placed in a straight format. When it comes to trans system, they are placed diagonally, either this way or this way, whichever way. Ensure that to identify cis, watch out for your hydrogen. Are they placed diagonally or horizontally? If they are placed horizontally, that's what there is cis system. If they are placed diagonally, it's a trans system. Now we have clarified that this man here is a what? Is a cis system. Why is it cis? Because the hydrogen are placed horizontally. That's first case. This man, this compound is called cis. Cis what? Now here's the concept. This is how you name it. I have done a video on how to name organic compound. I'll not stress myself here. You can check the playlist of organic chemistry for beginners. I've done a series of video from scratch on how to name organic compound. So I'll not stress myself here. I assume you have watched that. Now listen, please. For our rule one, when it comes to naming compound, the first task is what? Count the longest chain. In this case here, my longest chain is C 1, 2, 3, 4. So this man here is a 4. A 4 carbon atom is of course both. That's 6 boot. Next up, this man here is having a double bond. When it comes to naming double bond, you have to show the position of what? The double bond. In this case now, this is 1, 2, carbon 2. It means that double bond is attached to carbon 2. So that becomes 6 boot, then 2, the double bond here is alkene, that's 2-ene. This compound is called 6 boot 2-ene. That's how you name this compound. Let's name this man. Of course, it's clear this man here is a trans system. That becomes a trans what? Trans what? Trans, count the longest chain. 1, 2, 3, 4. A 4 carbon atom is boot. Trans boot. Boot what? This is 1, 2 double bond, carbon 2. That becomes 6 boot 2-ene. Why is it in? Because there's an alkene double bond, right? So this is how to differentiate between a cis and a trans system, and also this is how you name a compound in a cis and a trans system format. This is how geometrical isomers work. For the cis, they are placed horizontally, I mean the hydrogen. For the trans, the hydrogen are placed diagonally. That's like the concept behind a cis and a trans system. Let's take one more example to further explain cis and a trans system. Let's take one last problem to explain the cis and a trans system of geometrical isomers. So I have these two structures this way. So that is first, let's identify which one is cis, which one is trans. It's clear that this one here is a what? Is a trans system. Why? The hydrogen are placed diagonally. So I say for trans, they are placed either in this way or this way, diagonally. This one are placed what? There horizontally. Of course, I have HH, they are placed horizontally. This man here is a cis system. This one here is a what? Is a trans system. Let's now name them. So name this one here. It's easy as we said, count the longest continuous carbon chain. If I have, observe this, observe my counting. This is 2 carbon atom, 2, 3, 4, 5, 6, 7. Counting this way gives me 7. Observe this way too. This 2, 3. Okay, that's the only way I can count. That's the only longest chain there. This way gives me 7 carbon atom. A 7 carbon atom is called ept. This is called trans-ept. Why ept? I have 7 carbon atom. Second task is that this double bond here, I have to show the position of double bond. Now counting this way, this is 2, 3. Counting this way, I have 3 to double bond. Counting this way, this is 3, 4. I have 4. In between 3 and 4, the least is 3. That becomes 3-ene. This compound is called trans-ept 3-ene. Why ene? Because double bond. A double bond is an alkene. I have an ene here. This compound is called trans-ept 3-ene. Let's name this one here. To name this is quite easy. We said longest chain. Here is 4, 5, 6, 7. 7 is ept. Next task there, show the position of this thing here. This is 4, 5. Counting this way, I have 5 to double bond. Counting this way, this is 1, 2. I have 2. In between 2 and 5, the least is 2. That becomes -2, then your ene. Why? Double bond. That's why it's an ene. This compound is called cis-ept 2-ene. This is how you name this kind of compound. So this is how geometrical isomers works. So look at much more concepts in the study of organic chemistry. We'll look at the concept of hybridization in the next class. If you found this class helpful, do well to like, subscribe to my channel, leave a comment, also share to your friends and classmates. Also, to blow your mind, I have created a website In my website, you get more of organic chemistry courses there. You can go to this website to purchase the courses there. When you buy the courses, it's a lifetime access. It gives you a lifetime access to the courses. Also, to this website, kindly check www.ganiyu.com. In the website there, I have close to different science courses there that I can purchase. If it interests you, I also launched a book called The Shortcut to Academic Success. To get a book, you can just chat me up to my WhatsApp number. I'll be leaving above the screen, or you click on the link you see in the description. I'll drop a link to the payment to the book. If you're interested, you can do it to purchase the book. All right, guys, see you in this class, and welcome to Excellent Link Academy. We'll look at hybridization in our next class.